Good morning, student. Today we'll learn about design of microstrip line, and we will try to model microstrip line in high frequency structures. So, this is the simple structure of microstrip line. We already have discussed, but one more time, we'll discuss this. And this image is taken from the site EM Talk. This is a simple microstrip line, and it is very similar to the microstrip patch antenna. There is a ground plane you can see in the bottom, above which there is a dielectric material, and above which there is a conductor. There is a line. Okay, so how to calculate the design equation? How to calculate the width of this transmission line that we are going to see. Okay, so these are the design equations. I have taken this design equation from the book Microwave Engineering by D.M. Uzar. And in order to calculate the width of the line, some specification must be given, such as what could be the impedance of the line that we are going to design, what is the dielectric material that you should use, and what is the thickness of the that type electric material. Based on this specification, we can design width of the line. So these are the equations well defined, well explained in the book. Now, what we are going to do is we are going to design one model of microstrip line in SFSS with this specifications. Okay, so the specifications are the frequency on which line needs to be designed is 2 gigahertz frequency. Material that you need to use, that is a FR4. Then dielectric constant of FR4 is 4.4, and dielectric material height or thickness that we need to take 1.6 mm. So if we have the specification and if we put that in this equation, then the width of the line that we could get, that is equal to 3.05 mm. Okay, so that is what we are going to design. The length of the line we will keep, that is equal to 50. So this is what about the specifications and calculations. Calculation, you can put the value in these equations and you can find the W in. If you find that if you put values, that will come out to 3.05 for this specification. Okay. So now let us start that same thing in the. So this is your NSYS electronic desktop, we call it HFSS. Here you have to select the first symbol, that is on insert HFSS. Okay. Now let us again quickly look at the uh, figure of microstrip line. So we require one ground plane, one dielectric material, and one line. So we will try to make that. So first of all, we will make a dielectric. So we will choose a box from here. We randomly place it with random dimension. Okay. So here we have to set the following parameters. So I am taking one variable, that is sub x, and I want to place it into the origin. So I want to maintain the symmetry. So that is why I am taking it half the substrate in the minus x plane and half of the substrate in the plus x plane. Okay. My substrate should start at the 0 position and it should have length in the y direction. Similarly, it should start with 0 and it will have the height in the z direction. So that is why I am keeping this as 0. Okay. As soon as I will press, I will get it will ask me the value. So here I will put the value of substrate x, that is the dielectric substrate, that is 15 mm. Now here I have to press because I have to enter the variable that is sub x. here I put the variables of y. Now it is asking me what is the value. So I'm keeping it 15 mm because I want to keep the line length that is 15 mm right now. And here I have to put the thickness of the substrate that is V1. So now my substrate is already, now you can see the substrate, right? We are not doing anything else. We are just keeping the substrate as it is, just a vacuum. Now we will create ground. So in order to make a ground plane, I am selecting draw rectangle from the draw menu and I will randomly put it. Okay. Then this ground plane should have the similar size such as the substrate in x and y direction. So I am just, you can copy paste also, but I remember the dimensions, so I am not putting the dimensions. I'm just putting the value. So, so now you can see my ground. My ground plane is ready. My substrate is ready. Now what I need to do is I need to draw a line. So in order to draw a line, I will go in draw menu and then I will draw a rectangle in it. Then I will set the dimensions. Okay, I am going to keep the length of my line in this in along y direction, and I will keep the width of the line along the x direction. So here I'm going to put this as mine. I'm taking one variable that is line underscore w. That means line underscore, and I'm keeping it half of the line in the minus x plane and half of the line in plus x plane. Now I should put this. Okay, it is asking me the value of line underscore width, which should be 3.05 mm as per the date. I have to keep this line on the substrate. So I am keeping this as a on the substrate. That means at uh, so the I have to put the variable name that is now here I simply need to say x. So this is my line. Okay. Now you can see lines and this is line, this is ground, and this is okay. Now what I need to do in order to you will see in theory that microstrip line in microstrip line field is not only inside the dielectric, but it will have a fringing field effect, and because of that we have to put one box, air box, which should have the similar size uh, x and y size as the substrate, but it should have the height that is more than it should have more than 4 times the height. So I am just copying. So what I am doing is I am selecting the box, Control C and Control, and then I have to go to the create box and in sub z I need to multiply with the 5 or 4. So this is my box. Okay. Now I need to create a wave or long anything. So in order to do that, I need to draw a go into draw menu and I have to draw rectangle any. Then I have to change the plane to I think along the x along the y direction. So now I have to set the height and width of this rectangle. Now you must remember, you must know that the width of the port should be 3 times the width of the line. So accordingly, we will set the width. So for that case, what we need to do is, I am here setting the dimension because I already know that the width of the line that is line underscore w, I have to multiply it by 3 times and I want to keep half in the minus explained and having them plus explained. So I'm taking minus line underscore width multiply by 3 divided by 2. So x size should be what? Line underscore width multiply by 3. And what should be z side? Z side should be whatever the substrate size plus 1. Sub z plus 1. So now let us see how our rectangle is. So this is how it should be. This is the viewport or lump. This rectangle is for viewport or lump. Now I have to put the same rectangle at the end of the line in order to check what is the signal. So I will select the rectangle, Control C, Control. Here I need to just change the y dimension because I want it at the end of the line, which is sub y. So now you can see that I have created one more rectangle at the end of the line. So we are here we are going to give the input, here we are going to check the output. Similarly, here we are going to give the input and here we are going to check the output. Okay, but now we have created all the geometry. Now we have to assign the material. So in order to assign the material, we will select the first box, which is a substrate. We right click on it and we will click on assign material, out of which we will select the FR4 substrate. We will search for it and we will click this. We do not need to do anything. This box should be as it is. Okay. Now we will select the ground plane and the line, and then we are going to give assign bound. That is a perfect electric conductor. This should be made up of conductor. Here we are assigning perfect electric conductor. You can assign this as a copper also by going in the finite conductivity. Okay. So this is now this two planes are made up of perfect. Now we have to assign the input and output to this rectangle. For that we will select this rectangle 3 and then we will right click on it and we will assign this as a we will go in assign excitation and we will select wave. Okay. Just press next and finish. Same process has to be followed for rectangle 4. Right click on rectangle 4, go to assign excitation menu, select the viewport and click OK. Next, finish. So now everything is assigned to this geometry. Geometry is done. Okay. Now we have to assign the frequency on which it should be simulated. So I have calculated the width of the line at 2 gigahertz frequency. So we will keep 2 in the center. So we will take the frequencies with between 1 to 3. So for that, for assigning this setup, we have to go in HFSS and you have to go in analysis setup, add solution setup. And here we will set the solution frequency to click OK. Okay. Now we have to set the sweep. So we again go in assign setup and here you can see that add frequency sweep is not unable. So we'll again go here this side project manager and in setup one we will right click and we will add frequency sweep. Here sweep type we will select this as a start and stop frequency should be 1 to 3. Step size we are going to keep 0.1 which is already set. So we are not going to change. Okay. Now we will go for validation. So we'll select validate from here. Then once it is done, we will simulate it. So you click on analyze all. It will ask you to give the name line underscore whatever is your ID number that you need to set. Here I am setting line underscore. So you can see the simulation process which is going on. This will not take as much time as antenna simulation takes. So here you should have a message normal completion of simulation answer. Once this is done, you can go to the result menu and you have to click on create model solution data report, out of which you have to select rectangle. Select all of this four together or you can check one by one. We will first place magnitude and then we will place. So this is the value that you can get. You can see that S11 here, that is of grade 9. That should be below 10 dB. So this is what it is. We should also check for S22, that is also should be below 10 dB. So that is what it is. Now dB S11 if you see. Sorry. Now let us check S21. What is S21? When you give input to port 1, what is the output that is coming out of port 2? So line width here we are setting that is equal to 3. Okay. And we that is we'll put the marker here. Let us first of all increase the line width of S12. So this is what the result is. Now we'll double click on the fonts and increase the font size here. Okay, let's put marker. So in order to put the marker, we right click on the result in the same graph and we put marker, add marker. So at 2 gigahertz, will check what is the S12 and S21 and what is this. So S11, S22 are minus 13 dB and uh, S12 and S21 is nearly equal to minus 0.29 dB. That means this FR4 is a lossy material because of which we have some losses that you can observe here. Okay, we shall check the value in the dB magnitude also. So if we will put in magnitude, then we can see that if we are transmitting 1 volt of a power, then only 0.96 is coming out of port 2. So 0.04 that is lost because of the dielectric material, which is used here, FR4. Okay, so that is what the results are. Here you have to increase the size of the X and Y both like this for both the plot. Okay, for both the plot you have to repeat the same process. Select all of this and increase the line width to 5 so that you can properly see the result. For curve information you have to double click, again you have to increase the size like this. So this is what the design of a microstrip line and the result. Now, in order to see, if you want to see how the field will look like inside this, then in order to see this, what you need to do is you have to click on the box, which is the FR4, right click on it and plot. You have to go to the plot fields, E fields, magnitude, magnitude E. So you will see the field distribution like this. Okay. And now if you want to see that how according to the phase how it will go, and this is how you can. So what you need to do here in this case, now you have to design the same thing, but the specification for yourself here is what you need to do is, let me just the specification is here. What you need to do is you have to use Deroid material and then you have to use the dielectric constant that is 2.2 and height you keep it is at as it is at 1.6. So this is your homework. You once you complete this work in the laboratory, okay. The second model that you have to make is this. So this is the first model. This we will do along with everybody in laboratory. This is during laboratory and this is this thing you need to complete. Okay. So this is what about the video. This is all about the microstrip line design, and I am stopping here.